a few problems involving intersections of planes. And so we had example 23 was about the intersection of 3 planes. We're back to the intersection of 2, but we're throwing in the idea of trying to find the equation of a third plane. So example 24, find a plane, throw 2, 1, negative 1 perpendicular to the line of intersection of 2 other planes. So I've got a wee diagram just to kind of help visualize it. These are the 2 planes that we already know. And what we can anticipate is that we know something about the line of intersection here, and also therefore the plane has to be perpendicular to that. So we're really talking about creating a third plane such that it does make a point of intersection. So we're really talking about maybe drawing a third plane, if we kind of drew it at the end here. It goes down like that, with some third plane here, and because it's perpendicular to the other 2 planes, it's actually going to make a point of intersection somewhere. Not necessarily right there, of course. So a few things that would be interesting to know going to the very end. If we want to find the equation of that third plane, we're going to need a point on the plane, and we're going to need the normal vector. So that's the 2 ingredients we'll need for that. Do we have a point on the plane? Well, we're told that we do. Yeah, the point 2, 1, negative 1 lies on the plane. Do we have the normal vector? Well, hopefully you can see that the normal vector is actually going to be the same as the equation of the direction vector of the line. So whatever, if we can come up with a direction vector to represent that line, then we're also going to use that direction vector as our normal vector. So, do we have to find the full equation of that line of intersection? No, but we do need to find the direction vector. How do we do that? Well, going back to a couple of examples, I think example 22, we were looking at the line of intersection of 2 planes. What we found was that we've got a normal vector to one plane, a normal vector to another plane, and the line of intersection is going to be perpendicular to them both. In other words, the direction vector of our line is going to be the vector product of the 2 normal vectors to those 2 planes. Okay, so first of all, we can come up with the idea that direction vector is going to be I, J, K. My 2 normal, the 2 normal vectors are 2, 1, negative 1, and 1, 2, 1. And if I do my vector product calculations, I'm going to have 1 minus negative 2. In the second one, I'm going to have 2 subtract negative 1. And for the third one, I'm going to have 4 subtract 1, which gives me 3i minus 3j plus 3k. That's quite good. I could divide them both. Remember, I don't need to use that. So that's, we could say that d is 3, negative 3, 3. But we can also use, if we take a common factor of 3 out, remember it's just a direction we're looking for, so a simplified version of that is going to be everything divided by 3. Okay, so we've actually got a direction vector of the line, so we can say here that for the plane, the normal vector is going to equal the direction vector of the line. So we've got our normal vector, and we've also got the point, which is 2, 1, negative 1. So we can say that the equation of the plane is going to be represented by the vector equation n dot r equals n dot a. And we could say that well, n, what have we got, is 1, negative 1, 1. We're going to use x, y, and z. 1, negative 1, 1, dot 2, 1, negative 1. Okay, so r is our just our variable vector x, y, z, and we've got the normal vector, we've got the point, and therefore we can multiply that out and say our scalar product this time, x minus y plus z equals, doing a scalar product of the right hand side, 2 plus negative 1 plus negative 1. That gives me 0. In other words, the equation of the plane is x minus y plus z equals 0. Okay, so we're just using some of the information that's out there about problem solving, understanding the connection between the direction vector of the line and the normal vector of this perpendicular plane. Okay, so hopefully that's useful for you, and we can go on and start to solve problems with all sorts of intersecting lines and planes. Okay.